Or just start?
I think we can start right now, and I start
Okay.
recording too.
So, hi guys, I'm Suhas, and I'm part of the INTERalliance Leadership Council, and I'm going to be helping facilitate today's Tech Talk. So, INTERalliance's mission is to inspire and assist young talents to pursue the IT career in the greater Cincinnati area. And if you guys like to apply to the ILC, you can go to interalliance.org and you can apply from there. And if you guys have any questions, please type them in the chat, and I'm sure Cole will answer them whenever he's free. So I'll let Cole take over from here and introduce himself.
Hey, thank you, Suhas. I appreciate you helping set this up, and I appreciate everyone being here. I'm just gonna let you guys know in advance that you can type questions in the chat. That's more than welcome, but we've got a small group, so if you want to come off mute, and just ask questions, that'll make this easier. I want to make sure I'm not boring you guys, so if I start to go on a tangent or whatever and you're falling asleep, just like come off mute and be like, "Hey, dude, shut up," That'll be fine. We're here to have fun and learn what we can. So kudos to all of you for being here, taking the time to learn and actually be productive with your quarantine time. I'll tell you, when I'm not working, I'm pretty much only playing Modern Warfare. So not being as productive with my off hours as all of you guys. So I really hats off to you. So we'll start off. Let's do some presentation. Sorry, I work for Microsoft. We're the polo. We have Teams, so I'm not super used to using Zoom, but I'll do my best. So let's make sure you can see this. Can y'all see my screen? Yep. Okay, perfect. Thank you very much. All right, so let's get started on this presentation. I'll try to keep the slides to a minimum and talking to a maximum. Security alert. Let's just press OK. I never read those. So today we're talking about AI and ML in the cloud. And I'm sure that you guys, that's like 3 buzzwords right in my title, right? AI, ML, cloud. So we'll talk about what those things mean. I'm pretty sure you know the acronyms. If you don't, I guess AI is artificial intelligence. ML is machine learning, which is a sub-discipline of artificial intelligence. And then the cloud is not just what we have in the sky. I was hoping for a little bit more sun right now in the Cincinnati area, but it is also centralized computing. So we'll talk about each of these a little bit more in depth as we go through. And if you guys have questions or I say something confusing, just go ahead. You're not interrupting. It might seem like you're interrupting, but I'm down to make this a conversation. And that is completely fine. So a little bit about me. My name's Cole Conklin, and I'm a cloud solution architect at Microsoft. So solution architect is actually a pretty common title or role in a lot of companies, especially companies that have tech wings. And the cloud appended to the beginning really just means, right, that I'm specifically architecting solutions with the Microsoft cloud, which is called Azure. So the most common way to describe what I do is our customers. They could be they're mostly big companies for me in the area, in the Cincinnati area that you've probably heard of, big grocery chains and retail stores and such. They come to us with a business problem. I'll give you an example of one that I'm doing right now. They'll say, hey, every single day we get tens of thousands of invoices or receipts from our customers, either hard copy or a PDF. And we would love to get those in the cloud without having someone, right now they have to have someone literally look at the form and manually input all of the data, right? The amount, the item, the customer number, etc. And that they have like hundreds of people doing that all day, every day, and automating those processes with the cloud would be really important for them. So my role is to take that problem and figure out how they can leverage the cloud to solve that for their business problems and make that go away. So that's essentially what I do at Microsoft. I started about a year ago now. So I graduated this time last year from the University of Oregon all the way across the country. I'm actually originally from Oregon. I grew up in Portland, Oregon, and I went to the U of O. So my first time in Cincinnati was a year ago when I moved here to start work. I didn't even have a place. I just had this job with Microsoft that I had been offered that I was really interested in. So I kind of moved across the country sight unseen. I had never been to Cincinnati, didn't have a place. Microsoft like holed me up in a hotel for a month while I shopped around, but it's been really good. I love being here. It's a really good town. It's actually pretty similar to Portland. It is a city, but it's not too big. It's not New York or Chicago or LA or anything like that, but it's definitely not a small town. So I love being here. Some of my interests, I love watching the Oregon Ducks play sports. I don't know how much you guys follow college sports. It definitely drives my girlfriend and my parents mad how much I love watching those things. But I love watching football, love watching basketball. I like music. I like hip hop and jazz specifically, and I am a programming nerd as well. So this is something that I probably share in common with a lot of you. As I started programming in high school, I would go to programming competitions, join organizations such as this one, which is part of why I got involved. And doing code and learning about technology is just something that I've always been really interested in. I thought was a lot of fun. So it's a little bit about me. I love this slide, right? What is AI? Because there's like a million things that it is, and there's a million things that it isn't. And I feel like out there right now, there are definitely good definitions about artificial intelligence, but there are also a lot of definitions that can be kind of construed as misconceptions or not good ideas about what AI is. So, let's open this up to conversation. This is just going to make it easier for me to have a dialogue with y'all. So, who wants to give their best stab at a definition for artificial intelligence? You can come off mute, just shout it out.
If statements. Just a bunch of statements.
I love that. That's not bad. I love that. A bunch of if statements, right? Because artificial intelligence has to make decisions. So when you program if statements into your code, right, it's taking in information and it's saying, based on what I'm getting, I'm going to come to a different result. So you know what? That's not even one I've heard before, but that's really good because at its base, right, if statements are a form of your computer being and acting intelligently. So Natalia, that was good. Who else?
Putting human knowledge into technology or computers.
Human knowledge into computers. That is really good too. I think that was Suhas. Thank you for that. So this is, I took a couple of courses in college in my computer science major for artificial intelligence, and it was really interesting how the practice really started up, right? Originally, it was the theory of cognitive dissonance. I don't know if any of you have seen Westworld, the show on HBO. I really like that one, but that show portrays how people originally thought about artificial intelligence pretty accurately. The original intent wasn't just to make an intelligent machine that could make decisions, because they thought, oh, that's what basic computing is. They thought, well, humans are the smartest thing ever. No way a computer is going to be smarter than that. So how can we model the computer motherboard and the computer's programming to model human intelligence? And of course, as we see in the year 2020 on the dumb things people are doing on TikTok, that doesn't mean I hate TikTok. I've got the app, but yeah, humans are not the smartest thing on this earth with the advent of computers. So it turns out that wasn't the best path, but that is definitely how we got started with artificial intelligence. So thank you, Suhas. That was really good. So what AI isn't, and this is not saying that Suhas is wrong. It's not a computer version of the human brain. He was right that we developed it originally to be like a computer version of the human brain, but at this point, that's not what it is. It's not smarter than a human. So while a computer can have vastly more capabilities, right, because of its processing speed, there are still a lot of things that the human brain can infer and understand better and quicker than a computer can. These are still things that we're trying to grasp with. And it's, computers also not trying to kill us. It's a little picture of the Terminator. My parents say I'm too young for this movie, so you guys really must be too young, but hopefully you guys have seen it at some point. It's kind of corny, but it's a I'm the Terminator. It's it's a funny one. And what AI is, at its base, artificial intelligence is programming or functions that can learn, right? So this is where it differs from the original. Oh, why does that keep happening? Why it's different than the just being a bunch of if statements is if statements are logic, right? And that is the first piece of intelligence, is being able to take inputs and logically give you the correct output. And that is the basis for logic. But the other piece of artificial intelligence is learning. So it's able to logically make decisions, and then based on those decisions and the outcome of those decisions, learn from them to make better decisions in the future. And that goes into the second thing here, which is it's able to make decisions without being explicitly programmed, right? An if statement is an explicit declaration in code of telling a computer what to do. What we want to do through artificial intelligence is be a little more hands-off, and we're not going to tell the computer exactly what to do. It's going to learn, and eventually it's going to be able to do those things on its own. And it's a program designed by humans. I just put that one up there because, like the last part where AI is not trying to kill you, there's a lot of fear that, oh, it's going to learn so much and then it's going to take over the world. I'm a naysayer to Elon Musk. At the end of the day, we write the code, we know how it works, and we have seen no proof that an AI can get out of the control of humans. So maybe I'm wrong, and if I'm wrong, the world will end at some point because of computers and programs. But as of right now, what we do know is that programs are designed by us, so we can control them and we understand how they work. So why the cloud? AI and ML are really already their own discussion unto themselves. So what is important about knowing how artificial intelligence and machine learning work in the cloud? AI and ML are really compute intensive. They take these things like deep neural networks and other things that we're going to talk about. They take really powerful machines to power and run this code in a time frame that's efficient, right? Because your laptop might be able to run a deep learning kit, but it would take a week. But if you want something to immediately be able to make a snap decision like a human would, you need a lot of compute power. And that's really what the cloud is it is a bunch of servers that Microsoft, Amazon, Google has somewhere that's more compute than you can even imagine, that you can use on demand to run your programs, your AI, your ML. I heard the statistic recently from one of my coworkers. In the entire world, all of everyone's cell phones, which again, these are more powerful than a mainframe that got us to the moon. All of our cell phones, laptops, iPads, etc., all of them combined, for every single person in the world, personal computing power does not have as much computing power as just the cloud servers of Microsoft, Amazon, and Google combined. The cloud already has more compute than all other devices in the world combined. The second part is we're not all PhDs in machine learning. I'm not. I just have an undergrad degree. And so there are very smart people who have already designed these algorithms to perform machine learning and AI, and put those things on the cloud so we can already use them. So that's one of the cool things about working in AI and ML in the cloud in this time and place, is you can use the capabilities of machine learning without having to actually have a PhD in algorithms, which, oh man, my younger brother is a software engineering major right now at Oregon State, and he's having a lot of trouble with algorithms class. And I have some fond, some non-fond memories of that class, but I will tell you, even at the most basic level, some of these algorithms to design take some pretty smart people, and that's not in the cards from all of us. If any of you get a PhD in algorithms, you're going to make a lot of money and you're going to be very successful and happy, but not all of us have that kind of dedication. And then the last piece is people and businesses can focus on using AI. This kind of goes with what I was saying earlier, rather than building it. So they don't have to take a lot of time to build those algorithms themselves. They can just utilize what already exists in the cloud in order to help their processes. So, oh nice, we got a video. This is always the best part of class, right? When the teacher just shuts up and plays a video. So let's watch a quick one on the power of AI. Is this? We'll see. One sec. Can I just like play this?
You might have to like take the link and put it on like YouTube or something, like
Okay.
in a separate tab.
Jesus, I feel like a boomer right now. Can't figure out how to play the video. Nope, that's what if I just double click. Well, looks like we are not watching a video class. I'm so sorry.
That's fine. That's fine.
It was a bunch of Microsoft propaganda anyways. You guys didn't want to see it. All right. So let's talk about some of the ways that AI is used in business today. And we see these time and time again, especially in my role right now, when really what my job is working with businesses to help them with AI and machine learning. So one of them is business agents. You guys see this all the time, and more often than not, they're really just super annoying. And that's basically bots. But bots are actually really, really powerful. They automate a lot of operations that now people don't have to do themselves. They can understand intent and language and respond to them. And that's not a capability that really existed 10 years ago. So the majority of times that you go on a website and when those bots pops up, it's like, hey, can I help you? You know, that is someone who used to have to do all of that manually, but now companies can just deploy these bots and have all that work done from them autonomously. Another is person, object, and activity detection. This is sometimes used for security purposes, right? It can detect movement on the ground floor of a factory where someone's not supposed to be. It's good for safety. I know we worked with a customer in my region recently that is a big manufacturing firm, and they wanted to make sure that people always had helmets on the work floor. So they would have these cameras hooked up, and anytime someone would go through without a helmet, the AI would extract that image and immediately send it to the floor manager so they could see like, hey, they'd walkie-talkie him, hey, put your helmet on, you don't want to get bonked. AI assisted professionals, so they can help with things so that people don't have to do a lot of the legwork they had to before, which we've talked about. One example is like lawyers or litigators, when they're getting ready for a case, they have to literally read through like thousands and thousands of pages of transcripts. And it just takes forever, or they have, whatever, 10 paralegals do that for them. But now when you upload all of those documents to something with artificial intelligence that can extract things, you can say, hey, when did it talk about the killer's weapon? Or I don't know. I don't know anything about lawyers or legalese, but, and then it'll extract all the pages that had the text that they were thinking of. Autonomous systems, this is one that we really take for granted. I recently worked with Microsoft's API for route detection and creation, right? And that is some pretty hardcore AI stuff that for Uber, Apple Maps is able to take 2 points on a map and come up with the fastest route, like taking into account traffic, distance, like speed limits on the different roads, it's like actually a really powerful thing to create a route, especially in our complicated road systems between two pieces. And autonomous systems also is like self-driving cars. I really hope that those come soon. There are some people that are car people. They want like a nice Ferrari or sports car and they like to drive it around. That's not me. I like to kick back. I prefer to not be the driver. And so when there are self-driving cars, if I can afford one, I'm going to get one because it means I can just, like be on Instagram the entire way to work instead of having to focus and drive. So I'm excited for the advent of that. And then knowledge mining is a big one that we see too. This goes a little bit with like AI assisted professionals that we talked about earlier, but just extracting information from large amounts of data. So, right, it doesn't have to be text, it can be numbers, whatever, but being able to take in a bunch of information and then extract something useful to perform analysis. Okay, first demo time. So we're going to do, this is actually a really simple version of something I'm doing with the customer right now. I referenced it earlier, but this customer, and you can imagine someone has like a ton of receipts, that are coming in, and obviously people don't keep like a hard copy ledger anymore. Like it's not the 1800s, you know. Everything is in a database somewhere in the cloud, because auditors, like for tax purposes, once a year, sometimes multiple times a year if you've been bad, come through and they audit these companies' financials. So they have to check to make sure all of the numbers like make sense. So they need all that information of every single purchase somewhere online so it can be accessed quickly. So a lot of companies still have people taking hard copy invoices or receipts, especially, and this company is an international one. So most of the hard copy receipts are coming from Latin America and the Philippines and China. And so it could be multiple languages. It's a bunch of different forms. So we want something that can just be fed a form, read where the text is, take out the important things, and then put them in a database. So that's what the form recognizer is. So let's check this out. This one's pretty cool, and this is like an easy one. And actually, you know what, I'm gonna really quick, I'm gonna back up. Sorry, I get excited. And I'm gonna talk about cognitive services. That's Microsoft's like branding for our APIs for artificial intelligence. But basically what they are is, remember how I said that there are things that smart people have designed that we can then use. So in this case, a bunch of smart researchers and engineers at Microsoft made an API that can take a form and recognize words and learn which words are important for you and extract them. So all we have to do is we get to tag the forms and we send it to this web endpoint. It's just an API that's exposed publicly that you create in the cloud, and it sends us back the information like a database, a JSON object format that we can then upload to the cloud. So, right, it's AI, but we didn't have to build anything. It already exists, and we get to leverage what that AI does in order to make a business process a lot quicker. So let's go over there. So I just have some example forms here, and you can see the first thing that the form recognizer does is it already, when it gets a form, this is a PDF, is it can tell where the words are, right? And it puts a little bounding box around each one of the words. And it wants you to tag those words and tell you like tell it what they mean. So in these other ones, I've already created tags, right? I told it where the customer name is, where the customer address is, the invoice number, invoice date, invoice due date, charges, right? Because the other things aren't important. We don't need to extract the title. We just really want the invoice number, and you can tell it that, hey, that's the invoice number. You can call it whatever you want. And so basically, it'll take in a form, and hopefully once we train this AI, it's going to be able to take in any form of this type, right? Something that looks similar, and give us the information we want back. So tagging is easy as say, hey, this is the customer name. Here's the address. We'll click on all of these. Cupertino, California. Invoice number, invoice date, invoice due date, and charges, right? So now that we've labeled, you know, I did 5 as a minimum, but the more forms you have to train it with, the better, right? Because it learns from the more information it has. But we're going to say, hey, take those tags that we gave you and train a model based on what we just showed you. And let's see what the demo gods give us back. All right. So based on the training results, it gives us this model, and it tells us how accurate it thinks it is. So it thinks 100% of the time it'll get the charges. 100% of the time it'll get the customer address. Maybe 80% of the time it's not as sure for the customer name, invoice date, etc. So if this was production and we were working with an actual company, I would say give me 50 more forms to train it on, because 80% accuracy for the customer name is probably not going to be efficient for you. But for our case, that's pretty good. So let's see what happens when we want to give it a new form. So we're going to give it a form that's never seen before, and we're going to see what it thinks. All right, let's go. I think I put it on my desktop. Demos, test. So let's give it a form, and let's see what it predicts. Hopefully it gives us something good. If this entire thing breaks, you know, I'll look like a hack. Maybe I am, but okay, that's pretty good. That's really good actually for only 5 forms. So you see it took that blank form and it said, hey, First Up Consultants, that's the company name. Here's the customer address. Here's the invoice number. Here's the date. Here's the date it's due. And here are the charges. And the other important thing to recognize here is it also gives you a confidence. So you can imagine, even once you start automating these processes for a company, they still want to like have human intervention if the computer isn't sure. So they could set like an inflection point or a checker, you know, in the code to say, hey, when it's less than 90, when the computer's less than 90% sure, that form will enter in manually, you know, but as long as it's above 90 on all these fields, sure, go ahead, put it straight in the database. And you see in the case of this one, it got all the information correct. And this isn't something that someone would have to enter manually. They could just upload the file. You can automate this process with a loop, right? And it gives you the result, right? This is the result visualized, but it also gives you the result in JSON. That is not formatted really that prettily. Let's look. This is my Azure, my Microsoft workspace. I think if we go here, we can see, no, this is the wrong resource group. By the way, guys, this is what Azure, the cloud's like portal looks like. Not really important for what we're doing right now, but this is what it looks like. So let's see. Containers. This is just storage. Form recognizer container. Let's see if, no, okay, it's not gonna give it to me, sorry. But anyways, this is something right now that a process that's gonna be automated. So first demo done. Hopefully that was kind of interesting. You know, I told you guys, if you guys start getting bored, don't fall asleep, yell at me. All right, oh, and
how do you know how confident it is? How does it like decide how confident the thing is?
that's a good question. Basically, as it's going through and making a prediction, this is why I wanted to show you the JSON object. When I labeled these forms initially, it made a JSON for each one of these labels. So the JSON will include the tag, customer name, the associated text that I told it was there, and then this bounding box here, it will actually give all the positional data, you know, where it's located on the X and Y axis in relative to everything else. So after you train it and you give the analysis, one thing about these demo forms is they're all slightly off. Like you can't really see, but the bounding boxes are slightly in different places than the other ones, because based on, right, you can imagine based on the way someone scans a form, it could be a little bit different. So when the form is predicting something, you know, it's not the same words that it's used to, it's slightly different position. So it will give you confidence that how close it was basically to what it was expecting. So in this case, I mean, you usually don't get 100%, which tells me maybe these things are really, really lined up well compared to the training forms that I used. But like this one, this might have been a slightly different field, a different length. The box might have been a little bit in a different place than it was expecting. So it wasn't quite sure that this was the date, but it was pretty sure that this is the correct date that it grabbed. That makes sense?
Yeah, thanks.
Yeah, no worries. All right.
Then we also have a question in the chat.
Oh, sorry, I haven't been
Talia.
checking the chat. Well, what do we got?
She said, is there a general cloud every device uses, or do large companies need to create their own clouds?
That's a good question, kind of about the way the cloud works in general. So basically there is like the cloud is a bunch of servers. So Microsoft has these giant server farms. Let's see. Has these big like campuses that are super locked down. They've got like security guards with guns. Amazon has them, Google has them. Let's see if they have like a map, you know. I feel like I've seen a map somewhere at some point. Okay, I can't find them, but they're all over, you know. There are like 2 on the East Coast, multiple in the middle of the country. Really across the world, there are a bunch of different ones, and they're just these giant server hubs that are rows and rows and rows of computers that make up the overall cloud. When a company wants to use it, they are going to create an account with Microsoft, Amazon, Google, which are kind of like the three big cloud providers. And as they create resources, is what they're called. So a resource can be a data lake, a data factory, a cognitive service, right? It's going to allocate some part of those computers somewhere in the cloud intelligently to that customer. And then it's going to shut it off from the rest of the cloud so only the customer can access. So that's their personal cloud. And we have hundreds of thousands of customers who do this, and the network engineers at Microsoft are super smart and are able to get things to intelligently allocate themselves. So people get different parts of the cloud, but it's their own cloud that they own, if that makes sense. I don't know if that was a good answer. It's like it's hard to describe. It's like such a loose concept. Hopefully that helped.
Yeah, it makes sense. I'm just wondering, would it be more beneficial to make your own cloud on your own servers, or would it be just safer to use a large company's cloud?
So that is a great question, by the way. Thanks for asking that. That is kind of the reason that a lot of companies are now going to the Microsoft and Amazon clouds. Is traditionally in the past, most companies really did have their own cloud. So I worked at US Bank before I worked for Microsoft, and US Bank, being a financial services company, wanted to make sure that all of their data stayed on their own system. So they wouldn't want to put their data on Microsoft or Amazon because, right, that could be near other people's data, it's on other people's servers, etc. So they have their own data centers, right, that they spin up all over the place, and that would be considered their own cloud. So anytime you're on a US Bank computer, right, it's not talking to the public internet, it's talking to their cloud and their servers to run their own applications and such. But what happens is, let's say you are a big retail company in the Cincinnati area, and right now you have your own data centers. Well, your core business and where you get all of your revenue is from people buying your goods, right? So you want to sink as much of your money and your income as possible into things that are going to generate revenue. For you, that's activities such as supply chain, leasing, hard places like stores where people can buy your goods, purchasing your goods from wholesalers that people can buy, paying employees who manage the stores, right? And there's a whole bunch of costs then associated that you also have to hire an IT department. You have to lease land for your data centers. You have to buy parts to make a whole bunch of computers. You have to hire more people to manage all of those servers. You have to hire people to create applications on those servers and manage your whole cloud infrastructure. So what that is called is CapEx, or capital expenditures. So you're buying all of these things up front, and then you're using them. And so that's can be really expensive for a company whose core business is not IT or computing, because none of those activities are actually creating revenue for your company. They are just supporting your business. Now you have a company like Microsoft or Amazon who is really good at creating servers. They have, world-class talent making their cloud and making all these applications run. So you say, hey, well, I could just pay a monthly fee to be on their cloud, and I don't have to do any of this overhead to manage my own private stuff anymore, and I can have all of that data exist on Microsoft. So that's really kind of the idea. And the other piece that's really nice is, instead of having to pay up front to buy land, to buy computers, to set up computers, you just pay on the cloud as you go, as much as you use. So the first month I used, let's say, 200 terabytes of data, I pay for that. Next month is Christmas season and people are on my sites way more. I use 500 terabytes of data. That month I pay for 500. And then February comes and people aren't shopping as much, and I only consume 100 terabytes. I would only pay that month for that much. So it ends up just being a question of economics for a lot of companies who don't want to be investing a ton of money into something that isn't creating revenue from their business. And there's already another company out there that does it really well that they can outsource that to.
Thanks so much. That was really in depth. Thanks.
Yeah, no worries. Okay, let's go ahead, go to the next demo. Unless, do we have anything else in the chat? Let's see, I don't even know how to check the chat. God. Okay, Boomer. Let's see.
Yeah, we have another question from Vanya.
I'm going to get to this question. I've got a slide talking about work skills, if that's all right with you. Thank you for that question, though. I really appreciate it. We'll get to that one. So let's get through another demo really quick. So this one is just another example of taking something that people have already created and using it, and it's artificial intelligence. So in this case, it's computer vision, right? Being able to look at an image and tell you what it is. And what this is important for is, again, having a computer, like I used the hard hat example, having a computer that can constantly be watching, because you don't want to hire people just to watch things, and being able to monitor things and know when something's out of place or what something is can be really, really powerful. So for this, we just have some simple code. Thought I had it open, but let's check. Have some simple code. Oh no, that's my JSON. Okay. That, get out of my way. Get out of my way, screen share. All it's doing is it's looking at this endpoint, which is in my cloud, right? That's computer vision, and it is passing it. This is my file path, an image, and we'll see what we get back. So let's look at the image that we're gonna look at first. Look at this White House, right? You guys have all seen this White House. It's a pretty famous one. So in the code, we're able to just go ahead, execute that script, and it's calling Microsoft's computer vision API and saying, hey, what do you think of this JPEG image? As you can see, it gives you same thing, confidence intervals and whatnot, but it's saying, hey, that's a landmark. Its name is the White House, and I'm like 99% certain. So that's pretty powerful that a computer can just immediately recognize what something is. So let's look at another one. What is this? Pete Rose, I did the Cincinnati Reds, all-time hits leader. Don't know how many of you follow baseball, but right, let's see what it thinks about a baseball player, at the plate. So I think it's just called Pete Rose.jpg. Pete Rose. So we're going to pass it that image instead. Save that, run the script again. And so now it is saying, okay, let's see, outdoor, gray, what else? Let's see, baseball, person, outdoor player, grass, game. So these are like the things that it sees, batter, pitch, and then it'll give you a caption. The caption is what it really thinks is going on. A baseball player holding a bat on a field, 81% certain. That's really impressive for a computer to be able to recognize images like this. So this is a computer trying to figure out the overall image and the overall context. So this can be used for something like video indexing. So if you don't want to watch hours of film, let's say it's for a crime or whatever, you can give the computer something that it's listening on. Let's say you're looking for man black hoodie and you don't want to watch the 72 hours that's taped. You give the computer man black hoodie and it filters through every image, every single frame that makes up the video, and it'll pull out the ones where there's a man with a black hoodie, and then you can break down like a crime scene or something that way. That's a first example. I don't know why I keep going to crime for these examples, guys. I'm sorry. Promise I'm not a criminal, but that's computer vision. So let's go back to the presentation just because I know I'm moving slow. I tend to talk forever. Okay, so this is a basic, let's go back to presentation. God, are you serious? Got to start all over? Okay, let's look at its very basic what machine learning is. So this is what we call a single layer neural network, and this is kind of the base model for how a lot of machine learning is done. You've got different inputs. The computer associates different weights with each input. The computer does a mathematical function on the weights that are associated with the inputs, and it gives you an output. So this is a single, what we call node of a neural network. Now, in an entire neural network, as they're used in practice, is this output would then be an input of the next layer, right? So there would be several different of these neurons, and those would all be the X1, 2, 3, the outputs of the last layer for the next layer, right? And so on and so forth. So these things can get really complicated and convoluted. But the way one layer would work is, let's say input 1 is color, input 2 is number of legs, and input 3 is size. So let's say you got brown, 4 legs, medium, and it would have these different weights, and it would give a function, and it would spit out brown. Well, I know that it's brown, it's 4 legs, and it's medium. I think it's a squirrel. And let's say that's wrong. It was actually a dog. So when the machine learning learns, it says, hey, that size thing, you got a little bit too, or you didn't place enough importance. It was medium. Squirrels are small. So make this weight higher. And then you try it again and you say, okay, medium, brown, or sorry, brown, 4 legs, medium. But remember, the medium's more important. So it does the function again, and then it will correctly give you dog. So that's like the basis of how a single neuron will learn, is it will look at take the inputs, give you an output, and then it will look at what the output actually was, and it will adjust itself, adjust the weights of the different inputs in terms of their importance, or adjust the function itself to give you the correct output. Does that make sense? That's like the base of kind of how machine learning works. So, I'm going to go through these steps really quickly. This is kind of a more high level about the steps that go into doing actual machine learning. The first is you need to gather data. So this is not to create a machine learning algorithm. This is to do machine learning in practice. If you have something and you want the machine to learn something, these are the steps that you need to take. You first have to get data, right? Your model needs data. The amount of data really matters, because the more data you give a model, the better it's going to learn. And the quality of the data matters too, right? If it's just a bunch of random things that don't have any meaning, the computer's not going to really learn anything. It has to be data with intent. And the data can be any format, right? Image, we showed the computer can learn from images, the computer can learn from PDFs, the computer can learn from numbers, it doesn't matter. The second step is data preparation. So you have to make that data that can be really in any form into a usable form. So, right, a computer needs to take the image data, and often it will change that into binary. Or like with the PDFs, is it took that PDF and we gave it position and text data so that it was able to learn based on the positions and the text. It needs to be in a usable format for the data to actually be learned off of. And we split the data, this is a really important step, into a training set and a testing set. So 80% is going to be used for what I just described, for training the model, but we don't want it to see all of the data, because once we have a model that's done, we need to take data that it's never seen before and evaluate whether or not the model's any good. And if we give the model that we've trained data that it's already trained on, of course it's going to give us the right answer, right? It used that data to train, so it's already good at doing things on that data. We need to give it data that it's never seen before to see, hey, when it gets new data, is this thing actually going to work? Next, we choose a model, and this is what the data is going to be like trained on and what is going to train. And let's see, I'm going to skip over this part, choosing a model. Training, we talked about this a little bit. Evaluation, this is what I talked about with the 20%. You want to give it data that it hasn't seen before, so it can compare the results versus the actual truth, and you can evaluate whether your model is good enough or you need to create a new model. Parameter tuning can be a little bit more complicated, but what this essentially is there are different parameters within the training that you set. So one example would be the learning rate. So remember how I talked about, based on the result that you give it, you might you change the weights that are associated with the different variables. Well, how much do you change the weights, right? If the computer's wrong, do you change the weight by, let's say, 50% and make it really drastically change if it gets something wrong? Or do you change it by 10% and just make it incrementally more towards the result you want? That can change the way that your model is trained, and then the number of layers, right? We just looked at one layer of a neural network. The amount of layers can also affect how complex the model becomes, how deeply it learns. So when you guys have heard the term deep learning, that's just a neural network with a lot of layers. That's what we call a deep neural network. And then prediction. Once we have it, right, just like with that form recognizer, we give it something new, and then it's going to predict what it thinks it sees. So choosing a model and parameter tuning, the last one that I talked about, are a lot of times the hardest and the most time consuming steps. So a lot of times, or not a lot of times, this is a product, I was going to do this demo, but I don't think we really have time for what's called automated machine learning. This is kind of a higher level product that we have in Azure, but basically, and it's very code heavy to look at, which is why I'm going to skip it too, but it automates these pieces. So you give it data, you tell it what you want to find, and it will automatically create a bunch of different models with a bunch of different, what we call hyper parameters, and it will try all of them out, and then it will tell you which model is the best for your data, or it will give you results from all the different data pieces, and then let you go from there. It's pretty cool. But we're going to get on to, we had one of the questions about why to work in AI, or what you can do to work in artificial intelligence cloud fields, right? Just the why, I'm not saying money is everything, but making a little bit of money can be pretty nice. And this is one of those markets that is hiring, right? This is a time when a lot of people are losing their jobs. It's a really tough economy, but there's still a demand for high-tech workers. There isn't enough of a skilled workforce, right? And even me, someone from the West Coast, came to Cincinnati, was able to be a part of this workforce pretty quickly in a AI skilled job. And I mean, same thing. Organizations are expanding, and I can't believe I read this sentence. It will change the world. It will change the world. It's already changing the world. It just sounds so corny. But just to answer, let me look at the exact wording of the question again. What was that? How do I open the chat? Or Suhas, can you read that for me? I'm sorry to lean on you here.
Yeah, was the how to get started with specializing in cloud computing?
Okay.
And machine learning or AI, and what technical skills are needed to learn as an incoming college freshman?
Great question. Okay, so number one, the basis for all of this, right, is having some knowledge of programming. And I'm not saying that's going to be the end all be all, that you need to be able to be a programmer to be in this field, but having some knowledge of how code works is going to be really helpful for getting started and understanding some of the basis of ideas for what's going on. As far as other stuff, I can go ahead and maybe I can send this out to Suhas after and he can disseminate them. I have some good links on how to get started with skills in the cloud. And I can specifically show you ones that are centered around artificial intelligence and machine learning. The good news for you, and all of you, honestly, is that you are really young. And the fact that you're already here, taking in some of this information that I definitely didn't know when I was your age, means that you have a leg up and a head start on the rest of the competition. Just being aware of the way these things work is going to be really helpful. And then displaying interest and wanting to get started and doing online tutorials is really good too. And that's another thing that I will always be a proponent of. I honestly think I might have learned more from like Udemy and online tutorials than a lot of my classes in college. When there's something that you're interested in, literally Google how do I and then blank, and whether it's cooking or learn to kick a football or program some basic machine learning, that's going to be something that you'll find academies and stuff for online. So just continuing to push your skills technically is going to be really important. And then being someone who understands how this works, understands how this affects business, and is able to articulate that to people is something that is extremely important as well, because there are a lot of people, right, with the technical chops to make some of these things happen. But if they're not able to describe to business users or their superiors what is actually going on behind the scenes and how that's going to affect or drive a business outcome, then it's not going to be as useful. Let's see.
We have one more question from Rishi.
What's up?
Yeah, he's going back to the image processing slide, the demo that you showed.
Uh-huh.
Yes. Does the computer compare the given image, like the White House, to another image, and you'll see if they match?
No, that is a good question, but basically, once the computer has learned, there is no longer any comparisons going on. It's basically extracting components of what is in the image and comparing that with what it knows. So in the case of, let's see what it did again for the tags for White House, you can actually see some of this in the output. So it sees like dominant foreground color, white, accent color, let's see, outdoor house, building, street, standing clock. It takes all of these tags and different basic things that it extracts within the image, and those can be considered, right? You can think of those as the weights in the neural network, and it knows, well, as far as thinking that this is a landmark, if it's a big lawn, a field, a white outdoor house, then those are things that I know can be really important for having the output of White House. So it's not comparing it against any images, it's extracting components of it and using those within functions, what are called weighted functions in its neural network to come to an output, is how that is working. And then continue on what I was saying, AI workforce skills, right? Mathematical skills are very important as well. At the end of the day, machine learning and artificial intelligence stuff it's all math. That's really what algorithms and stuff is. So probability, algorithm, statistics are important. And then, as I said, programming skills. If you can program in one language, you can kind of program in all of them. But Python and R are the most commons that I see in the field today. I nearly do everything in Python. And most of my customers within the machine learning space do too. And then being willing to learn new things is super important. What else do we have?
Can you lose something in the cloud because it is so vast?
That's a good question. And that's something that, a million customers, especially ones who don't understand the cloud, definitely have concerns about. But what Microsoft does just to make sure, right? Because even an individual server could just like burn out, you never know. And if your data was on that, you would lose it. So whenever you create something in the cloud, and this is free, this is just anytime something's created, at least in the Microsoft cloud, it makes 3 copies of your data or of your resource in 3 different servers within the same server center. And then you can pay more for things that we call like geo or zone redundant. Like you can have copies in another region or somewhere else in like another continent in case there's like a natural disaster. Let's say the entire eastern seaboard got wiped out and all of your data, cloud stuff was running there. Well, that's going to be gone, I guess, because there was an earthquake that took out the entire server farm. But you could have duplicated it, paid more, and had that data exist in multiple places. It could be in China too, so that's what we call geo redundancy. That is a good question though, and that's something that we get have concerns about from our customers all the time. Anything else, you guys?
Oh, and earlier you said you would share me the link so I could send it to them of like different things to learn.
Yeah.
AI
Here,
stuff.
I'll show some of these actually. Let's see. Microsoft Learn. I'm not joking. So you guys, I was not like I was pretty good at computer science and like machine learning specifically, but I had never used the Microsoft Cloud when I started here. So I used Microsoft Learn just a ton for all sorts of stuff. So I'll drop this in the chat. And I've learned a ton even like since starting work from these things. They're pretty high level, they don't go super deep, but you can definitely take what you learn in them and expand on them. I'm so bad at this. How do I get the chat back?
I think it's the last
Tab
on the bottom of your thing, like taskbar.
There we go. All right, here's Microsoft Learn. So within that link, you can just go to you can go in here and you can look at different learning modules. What I would do is I'd go through these learning paths and you can search. Let's just look at machine learning, right? And there are different modules and stuff that you can go through that will help you try a machine learning model. in Azure, and we'll take you through all the different steps to get started. So right, just within machine learning, predict flight delays by creating a machine learning model in Python, working with data in Azure machine learning, etc. So there'll be all sorts of kind of things you can go through, and they're honestly really comprehensive. If you follow step by step, you'll be able to do it. And they're pretty easy and they're really good. And those are the main ways that I learned how to apply some of my machine learning skills specifically to the Microsoft Cloud. So
Are
that
all
stuff
these
is
things, are they all free or like you have to pay for them?
all free. I believe so. The part that would cost is the Azure subscription. But I believe you get a, let's see. I think it's free for students, something like that. Yeah. Okay. So when you create a student account, it's going to give you $100 credit for free. All of these, like, you guys have to understand the way that Microsoft makes money on the cloud is it's companies that are streaming hourly like hundreds of terabytes of data. Like anytime I do a POC with I did a POC with a customer last week that was like 100,000 PDFs going through, and it charged like $24. Like, until things are on a massive scale, they don't really cost anything. So $100, like, you could go through all of these modules right here and you're not going to spend your $100 in credits. So that's what I do is I'd create an account, do the student thing. I guess I'll drop this in the chat as well. And yeah, the $100, I mean, it's not, Azure doesn't really cost anything. So all the modules are free to go to, like to read the documentation. The only thing that could cost anything is the actual cloud resources that you create, but they're very cheap when you're doing it on an individual scale, if non-existent. Like it's going to charge you like 3 cents to create your one machine learning instance.
Okay, thank you.
Yeah, no worries. Anything else? Okay, well, I hope this was helpful, you guys. I enjoy being here and being with you guys. If there are any other questions that I can answer you, I'll go ahead. I'll put my email in the chat. You guys can feel free to reach out anytime. I'm really happy you're all here and you're all engaged. This is a huge leg up for all of you above the competition. Like, you guys are getting started early. You're doing great stuff. So all the best.
If you guys have any more questions, you can unmute yourselves and say it. Oh, we had another thing from Natalie. She was wondering if you could share your like machine learning demo. If it's like, if not now, like email to me and then I can get it out to them in the future.
Yeah, sure. No problem. I would love to. I'm sorry that I was a little bit over time, or I guess with my other stuff, but yeah, I'd be happy to show the auto machine learning. It is a little, that one, I think I actually have it up right now. This one is a little more like code intense. This actually does do some more machine learning data science type of work, but yeah, I'd definitely be happy to share that at some point.
Okay, thank you. Well, thank you so much for joining us today. It was really helpful, really interesting. And I think as we're recording this, I think it's going to be going up. I think it's going to be going up on YouTube shortly, if that's okay with you.
Yeah, that's cool, man. I'll be looking out for it. Yeah, send me a link. That's awesome.
Yeah, yeah, for sure. We'll send you